Okay, as you can see from the slide, I hope, the speaker today is Doug Phillips. That's me. I do general scientific computing consulting here at the University of Calgary in a research computing support group. I spend most of my time these days supporting people on the WestGrid system, end user support of various kinds, account administration and programming support, application software support, and so on. So Matlab is just one of the things I have a chance to look into from time to time. I'm not a Matlab user myself in a sense. I do help people with their Matlab concerns and install Matlab on various WestGrid systems and so on. So I'm somewhat familiar with it, and I guess that gives me the qualification to give this talk on using Matlab on WestGrid systems. The audience is fairly sparse, but I hope the people who are here fit into this category of researchers with Matlab code to run on WestGrid. If you're not currently a WestGrid user, maybe the talk today will give you some ideas as to whether it's worthwhile to invest the time to get a WestGrid account and start using WestGrid to run your Matlab code. Most of what I'm going to be covering today is on the WestGrid website in one form or another. The main address where you can get into the discussion of Matlab is shown there. But the key point to come away with is if you have any kind of technical support questions, whether it be about Matlab or others, we have the support mailing list, support@westgrid.ca, where you can submit any follow-up questions that you might have, or months from now, if you get started with Matlab at that time, we can deal with your particular issues then. I find that one-on-one support is really the most effective. For some software like Matlab, there may not be a Matlab expert at your site, so we'll still do the best we can to give you a flavor of one-on-one support if you write to support@westgrid.ca. Okay, so let's get into the content of the talk here. We've covered the introduction, and the next little bit will be why you might want to run Matlab on WestGrid. There are several different ways to run Matlab, and one of the things I'll emphasize is that licensing considerations are an important factor in deciding which way you run it. There is some provision for some researchers to run the regular full-blown graphic user interface version of Matlab. There is also one server, the Orsness cluster, that runs something called the distributed computing server, and there's the opportunity to use multiple workers for a job to speed it up using the distributed computing server. But the favorite way, I would say, from my point of view, for using Matlab on WestGrid is to create what's called a standalone application, and this avoids some of the licensing issues that the other approaches have. So there'll be 4 or 5 slides on that particular approach, whereas there'll just be one sort of quick overview of the other ones. Then there'll be a similar summary slide and a reminder again of support@westgrid.ca as the place to go to get help. So presumably you're here because you have an inkling that Matlab running on WestGrid will help you overcome some kind of limitation in your own environment. It may be that you just have one PC to work with and you just want to offload some work. That's a legitimate use of WestGrid, but maybe not taking advantage of it to the full extent. One of the ways in which WestGrid can really shine is to allow you to run many simultaneous serial jobs at the same time. With one of the approaches we'll discuss later, there aren't any licensing issues around that. You can run potentially 100 instances of Matlab at the same time. Another limitation you might find is lack of memory on your own machine. And so running on WestGrid will give you access to some large memory machines, up to 250 gigabytes. Another reason why you might want to use Matlab on WestGrid is to increase the degree of parallelization in your code by using more cores for a single run or by using multiple nodes at the same time. One caveat in all of this is that WestGrid is not well suited for MATLAB development. So you're expected to have your code written, say, on your own machine or an institutional machine that you have access to, and then you transfer that code to WestGrid to run. There's still the opportunity to do some debugging and to make changes directly on the WestGrid systems, but overall, you're expected to do most of the interactive work on your own machines. So as I mentioned before, and will several more times probably, licensing considerations are a big part of the history and the present situation with MATLAB on WestGrid. Back in 2009, I think it was just about 4 years ago, we sent out a survey of what software people were interested in using on WestGrid, commercial software that we might be able to purchase for them. And MATLAB came up number 2 on the requested software list after the Gaussian quantum chemistry program. And I got the impression over the time since that many people wanted to use MATLAB in the same way as they might use it on their own PC, and maybe got a little discouraged starting up with MATLAB. But we have had a steady flow of users for MATLAB since. And WestGrid did actually go ahead and spend money on MATLAB licenses for what's called the distributed computing server. And we purchased 64 workers for something over $10,000 a year. And the first couple of years, there wasn't really very much usage, but I think more recently it's used quite a bit by just a handful of researchers. And then again, we come to the one I said was my favorite, compiling and running standalone applications. I guess with each one of these, I'll have some slides, and maybe I'll comment again on how the particular licensing issues arise for the three main ways there of running MATLAB. A key point about the licensing is that there's always some kind of local license that's required. You don't get a free lunch. Well, you get some donuts here maybe, but with MATLAB, we have to pay for it one way or another. Or you have to pay for it one way or another. There's different kinds of licenses. There's licenses you have on your own PC, perhaps. Ones that are relevant there are the compiler, if you're going to be using the standalone application approach. The parallel computing toolbox is needed if you're going to be using the distributed computing server. And then for your own development, you need MATLAB and the other toolboxes. At many of the WestGrid sites, there are institutional licenses to MATLAB of some kind that can be used, that more or less the same kind of licenses you'd have on your own machine. And then on the WestGrid Orsness cluster, there's this particular consortium license for the distributed computing server and the 64 workers that are available there. I kind of argued with the MATLAB salesman when they first proposed this special license for institutions like, well, collections of institutions like WestGrid. And he was adamant that the head office was not going to change their approach to how this is licensed. It would have been much nicer had we been able to use more of the regular MATLAB licenses instead of this consortium license. We'll see more about that in a moment. Okay, so now I'll get on to the individual ways that you can use MATLAB. I see a little tiny video pictures of the different rooms that this broadcast is going out to, and It would be possible to interrupt me with a question partway through. If you want to talk to the local collaboration coordinator in your room and unmute your mic and ask a question at any time, you can jump right in, I guess. Otherwise, we'll just have time for questions at the end. I should have mentioned that at the start. Okay, so the slide here is on using the full-blown regular version of Matlab. One thing to keep in mind is that where Matlab is located on the system depends on which of the WestGrid clusters you're using. I'll risk trying to go to this address here. I had meant to make that a link that I could click on, but it doesn't seem to come out that way. On the WestGrid website, there's a page that has a list of the major software packages that have been installed. And this page expects you to have quite a wide screen, or a lot of pixels on your screen, which we don't have for the presentation here, but I think I can scroll across and get my point across. There's a line in this table for Matlab, and the different columns correspond to the different WestGrid clusters that it's available on. And you'll see at the top of each column here, there's an indication that the particular installation is available only for a certain group of researchers. So this first column here is the Breezy cluster, which is physically located at the University of Calgary. So one of the limitations of these regular Matlab installations is that the license only allows for us to permit researchers from a particular institution to use the software on hardware that is located physically at that institution. So for Calgary, there's a couple different systems: Simon Fraser, UBC, University of Manitoba, University of Victoria, and UBC. So you can see that some of the other WestGrid institutions, such as University of Saskatchewan, Regina, and so on, are not listed here. There may still be a local resource for running Matlab that might have the Matlab compiler license available, or might have the Parallel Computing Toolbox license available, but you'll have to investigate those things locally. Okay, so back to the regularly scheduled talk. So that was the point I was making here, that researchers from the institution hosting the hardware is a limitation on the licensing again. The graphical version of Matlab, or even using the regular Matlab in a batch-oriented fashion, is not something we really strongly promote, because each job that you submit would use up a license token. And so a more typical use would be just to use the Matlab that way, just temporarily for compilation or post-processing or remote job submission to the distributed computing server. There are some examples of how you can use it for batch job use at this website here. Again, one of the ones that's under the main Matlab heading on the WestGrid website. If you are going to use Matlab interactively, then you should also refer to the quick start guide for the particular system that you're going to use. You can request some processors with this Q sub -I, and if you're using the graphic interface, you'd need a -X for X windows. And these kinds of issues are outlined in that quick start guide, and they vary a little bit from WestGrid site to site. Okay, the next major way you can use Matlab is with the distributed computing server workers. I won't go into any of the details of that. I'll just mention some of the advantages and disadvantages. The main advantage is that you can increase the degree of parallelism. If you're running Matlab in parallel, you could use up to 64 workers for a single job and speed up your code considerably that way if it happens to be using an algorithm that benefits from that many workers. However, since the 64 workers are shared potentially among different users, you might submit a job asking for 64, and then it will have to sit there until all of the licenses are available. So that's one of the disadvantages. Also, this runs only on the Orsonus cluster currently. We do have permission from Matlab to run it on other clusters, but there were some network licensing issues and so on that prevented that from happening. And then because this 64 processor limit is reached quite easily, there's maybe not too much point in running on other systems, except if you happen to need large amounts of memory. In order to get started with the distributed computing server, you have to install some scripts in the local installation of Matlab on your own machine. And you also have to have a parallel computing toolbox license. And this is used to submit jobs from your machine to the distributed computing server on Orsonus. And this is potentially time-consuming to debug the initial setup of this. We've had some of our longest email threads, I think, on the support list have been about trying to get people started with the distributed computing server. So that's sort of left a bad taste in my mouth about it over the years. And I don't want to be too negative about it because there is this distinct advantage. But I'll spend the rest of my time on the other approach of creating standalone applications. Matlab, in their wisdom, created the Matlab compiler, and it allows you to distribute the results of your Matlab programming efforts to other people free of charge. You can use the compiler, which is one of their more expensive products. It's about $500 a year. You can use the compiler just briefly to compile your code, and then somebody else could use that expensive $500 license. But you just need it while you're compiling your code. You need the compiler license. And then when you go to run your code, there are no licenses involved at all. So if you wanted to run 100 instances, as I mentioned, of Matlab, you could compile your code once and then run this compiled standalone application each of the 100 times that you need. Another advantage is that you can use more or less any of the Matlab systems to run the compiled application. It's not just confined to the Orsonus cluster. And in particular, the large memory Breezy cluster is appropriate for jobs that are too big in terms of memory for the other clusters. And you can use up to 250 gigabytes of RAM for a single job. There is a licensing limitation on the distributed or the standalone applications that you run, regardless of where you run. You can use a maximum of 12 cores for a single job if you're doing parallel processing. I should mention that this is a limitation that's in the last couple of versions of Matlab. Older versions of Matlab had a more restricted license. You could run, say, only 8 cores. So if you are going to be using a Matlab compiler, I'd encourage you to use the most recent one that you can, a 2012 version at least. That will give you this 12 cores, whereas I think the 2011 and earlier would be restricted to just 8 cores. In terms of disadvantages, I've mentioned you have to have a compiler license. I didn't mention yet that you have to run the compiler on hardware and operating system environment that is compatible with the WestGrid systems. Typically, just about any 64-bit Linux operating system-based computer running Matlab with its compiler would be sufficiently compatible. So this means that you might have access to a central computer, say, at your own institution running Linux. You wouldn't have to necessarily have Linux running on your own computer. And so if you're at the University of Calgary, for example, the Storm cluster here can be used for the compilation part of this, and then you could transfer the compiled code to a WestGrid system to run. One other limitation of the compiled application approach is that any parallelism you can exploit is limited just to a single compute node when your code runs. You can use up to 12 cores on a single compute node. But you'd have to use the distributed computing server approach if you needed multiple nodes. There are three major steps in using the Matlab compiler and creating and running these standalone applications. The first one's compiling, then there'll be something called deploying, and then running. So I'll spend one slide on each one, and that'll pretty much use up the time I had today. I had originally considered to do some sort of live demo, but that's always dangerous, and if you're really interested in that, then maybe we can take the time after the scheduled time. But the basic idea is that there is this program called MCC, the Matlab compiler, which you can run on a command line, just as MCC and some options, and then a list of the source code files that you want to compile. The actual path to MCC will vary slightly depending on the WestGrid system that you're on. So there's an example of the compiler options at this website here. I'll click there and see if I can get there. Yes. This little bit here, I hope it's not too small for you to see. The first line here is making a directory called deploy. It could be named anything, but in this particular case, it's structured so there'll be a separate directory for the results of the compilation. And there's the Matlab code to be compiled in a separate source code directory. So we change to that directory and then run the compiler to compile this code, mycode.m, which can consist of a number of Matlab functions and so on. It can call other Matlab code, and the compiler is supposed to be smart enough to figure out the dependencies and compile that all in, but if there's any doubt, you can list all of your Matlab source code files on the MCC command line. And there are other directives here that you can use to specify which directories MATLAB should look into when it's doing this compilation. There are a number of options here. I'll just explain briefly. When the compiled MATLAB code is run, it's going to be submitted to run as a batch job on WestGrid. You're not going to be interacting with it while it's running, so there won't be any display, like a computer display that you're showing graphical results on. If there are any graphical results from your compiled MATLAB application, those will be written out to a file if you've programmed it that way. So we have an option here to say that there's not going to be an X Windows display. For some codes, there may be an advantage to turning off the Java virtual machine, although I think that's less important than it used to be. But the most important one here is this one, single computational thread. MATLAB by default will use all of the cores that are available to do some parallel computations for certain kinds of linear algebra. It will try to take advantage of the cores that are available. But if you're running on WestGrid, you might have a job that's assigned to a compute node that you're sharing with other users' jobs. And if you're both competing for all of the cores on the node, then everybody loses in a sense. So when you submit WestGrid jobs, you specify how many cores you want to use. And that needs to be coordinated with how many cores MATLAB will actually try to use. By telling MATLAB to just use a single computational thread, then this process becomes easier. If you leave this off, then essentially you have to ask the WestGrid batch system to use complete cores so that you're not conflicting with other people. If you're just running serial MATLAB code, then you use this single computational thread argument. Okay, so after this MCC command runs, then it produces a couple of files. So if we compile mycode.m as the first source code file, it takes the name from that. It would produce, as a result, two files: an executable code, mycode, and also a script, run mycode.sh, which sets up the environment that is needed in order for this mycode to run. So after you've done your compilation, then you go through this step called deploying, and that's basically copying these two output files to the WestGrid machine that you want to use. So here's an example of using the sftp command to go to checkers.westgrid.ca, and I left out a few things that would appear on the screen in terms of logging in, but then you could make a directory, change to that directory, and then put your code. That would transfer the files from the machine on which you compiled them onto the checkers cluster. And after you've deployed your code like that, then you want to run it. Running these compiled applications is like running any other code on WestGrid. You have to have a batch job script, and this running jobs page here goes through all the details of using the qsub command to submit jobs and monitor jobs and so on. But the Matlab part of this is really contained in just these two lines. MCR equals is the location of what's called the Matlab compiler runtime files. When you compile your code, it doesn't include everything that is needed for Matlab to run it. These Matlab compiler runtime files also have to be installed on the machine that you're going to use. And we've tried to install that for you on all the WestGrid machines where Matlab could be run. And it's always under global software Matlab MCR, except on the Bugaboo cluster where it's got a different location. But the location of these support files that are needed are used as an argument to this run script that Matlab created, the Matlab compiler created. If your program itself has any arguments that need to be passed to it, then these could appear after on the command line. Once you have this little batch job created, then you can submit the job. But I guess I'm skipping over one important point that I'm almost out of time, but I'll take a moment to mention this. There's a table on the WestGrid website here for the Matlab compiler that gives you the compiler version and how that matches up with the Matlab component runtime version that you have to specify. So if you're using a recent version of Matlab, say the 212B one, 2012B, then that corresponds to V80 of the Matlab compiler runtime files. So it's not an obvious correspondence between these. If you're using one of the older ones, then you'd have to specify these other runtime files. And not all of the WestGrid systems have all of these files installed. So if you find that you don't have the one you need, then first we would encourage you to use the most recent version to save us some work and to give you the benefits of the most recent version of Matlab. But if you really had to use one of the older versions, we could install it for you. Okay, so then that was the second last major slide, I guess. The last one I want to deal with is just a few considerations for how you might have to change your code in order to use the Matlab compiler. There are a few things, for example, untrained neural network code that don't compile with the Matlab compiler, but they've been adding more and more features to the compiler as the years have gone by, and now almost everything compiles. You should avoid hard-coded paths in your code. I see a lot of this where somebody has a C:\\/ something in their code, and they have to change that in order to move their code to the WestGrid environment. Another thing I see quite often, if somebody's working on their PC interactively, they might just change a number in a code and rerun it. A better way to handle the situation of running the code with multiple input parameters that you might want to change is actually using command line arguments or reading those parameters from a text file. Because every time you make a change to your code, you would have to recompile. So if you're just changing one number for each of your 100 jobs, say, you don't want to have to recompile 100 times. So if you can restructure your code so this one number that you need is passed as an argument, then that saves recompilation. Another kind of argument you might want to pass to your code is the number of workers that you want to use. Because you want to, if you have parallel code, you want to match the number of the Matlab pool workers that you ask for to the number of cores that you request of the batch job system. Okay, so I'm 1 minute over time here. And so I'll just put up the summary slide indicating that there are several ways to run Matlab, and the licensing may determine how you want to approach this. Parallelism and memory issues are also involved. But to my mind, using this approach of creating a standalone application that you then deploy and run is the most flexible way of using Matlab, and it actually suits many researchers. And again, the follow-up email address, support@westgrid.ca, is there, and we encourage you to write to us and explain about your Matlab code and why you might want to run it on Matlab, and we can help you get started. So thanks very much. I'll open things up for questions now, if there are any. Okay, well, we'll discuss those things after, I guess, yes. So it looks like we're good to go then. Thank you very much for your attendance. This was the last of the WestGrid seminar series this winter. I guess we're about to be spring. It might be called the spring series too. We'll certainly announce through a WestGrid newsletter on the WestGrid website when future seminars are happening. We encourage you to come to the HPCS conference in Ottawa later this year. There's some information about that on the WestGrid website. And bye for now.
Hey, Doug. Doug,
yes?
Before you go, we have one question here at SFU. See if you can help. So go ahead. Just speak fairly loudly so you can hear you.
Okay. Is there any support available for everyone who looks at the website and sees frequently encountered problems that have some posted answers to them? Like certain error messages and some certain resolutions?
No, I don't think there would be any particular MATLAB-related frequently asked questions. The greatest number of questions we get are related to the distributed computing server right when people are starting up, and the problems tend to be a little bit unique. Maybe somebody has installed the scripts on their own machine incorrectly, and there just haven't been enough people trying things to develop a data bank of question answers like that, I think. So at this point, just ask your questions on the WestGrid support list, and even if they've been asked before, that's okay.
Yeah, so don't be afraid to use the support@WestGrid email list for things like that. Thanks, Doug.
Okay.
Thank you.